In today's video, we're going to be making elemental boron, starting with boric acid. You can also start with borax if you have that instead, but that requires the additional step of adding the borax to hydrochloric acid to precipitate boric acid while leaving sodium chloride in solution. So the first thing that we're going to do is dehydrate the boric acid into boron trioxide by heating it. And as you can see, the boric acid is a really light, fluffy powder, sort of like powdered sugar consistency. So now we're just going to heat that up and try to drive off the water. I'm doing this in a ceramic, like a flower pot base, because boron trioxide is supposedly very glassy, and I imagine it will be pretty hard to get off of whatever container I'm using. So I'm just going to use something that I don't really mind destroying if I have to. So we'll let that heat up and dehydrate, drive off the water, and we'll come back when that's finished. I've been heating for about 10 minutes now, and you can see the water is coming off as steam, and the boric acid has clumped up significantly as boric oxide is formed. It's also discolored slightly, whereas boric acid is a bright white. A couple of these chunks have darkened a little bit. You might not be able to see that on the camera. So I guess we'll just keep heating until most of it looks like some of the larger pieces there. This is actually pretty cool to watch now that it's really going. This stuff is turning into just this really sticky, thick mass that just keeps bubbling up. And so I'm just going to keep poking at it with this just to get everything evenly heated. Try to break it up a little. Alright, it's been about a half hour since we started heating this, and the off-gassing has slowed down significantly. So that means that most of the water has been driven off, and you can see what's left is just really gooey, glassy substance, which is definitely going to stick to this plate, and I'm definitely going to have to destroy it. So it's a good thing I did that. So since this looks like this is about done, I'm going to turn the heat off. Let it cool back down, and maybe try to scrape some of this together so I can try to avoid destroying my thing anyways. Well, I managed to scrape most of it off of the plate here without breaking it, so congratulations to me. I started out with 15 grams of boric acid, and now I've ended up with 8.5 grams of boric oxide, which is hardened into this really, really tough glass, which is really difficult to break. You can see there's little bits of red in there. That's just impurities, just remnants of this thing that have scraped off and stuck to the boric oxide. I don't think that's going to be a big problem for the next step of this, but now what we want to do is grind everything down into a really fine powder, and I'm going to do that in my mortar and pestle. Alright, after a lot of work, I managed to crush the boric oxide down into a pretty fine powder. That stuff was really hard. It's very resistant to smashing, so that took quite a while. You can see that it's got sort of a red tinge to it, and again, that's from fragments of the pot that I used in the last step. So now what we're going to do is mix that with some magnesium powder that I have here, and we're going to basically turn this into a thermite. So the reaction is going to be between boric oxide and magnesium, and it's going to produce elemental boron, magnesium oxide, and a little bit of magnesium boride as a side product. So let's mix this up and see what happens. Alright, here's everything all mixed up and ready to go with my now familiar ignition method. I probably really didn't need to use the magnesium ribbon, considering the entire thing is made of magnesium, but I want to give this the best chance possible of igniting, because I really don't want to have to go through that whole crushing process again. So let's light this sucker off. So the difference between this thermite and any other thermite is I'm going to have to cover it too, to prevent the boron from reoxidizing in the air while it's still hot. So I'm going to throw a pot over this thing when it's done. So hopefully that will protect it from the air while it cools down. So here's the products of the reaction after it's cooled down and been uncovered. You can see the black there is from the glycerin reaction that was used to start it, and then all the white there around it is magnesium oxide. So hopefully we've got some elemental boron somewhere in that mass. So now we're going to move on to the last step of this, and that's to dissolve the reaction products in hydrochloric acid. So I'm going to powder this up and we'll move on to the final step. Alright, here's everything all crushed up. And now the final step is to burn off everything that's not boron. And to do that, I'm going to use hydrochloric acid. But this step you have to be careful, because the side product of magnesium boride, when combined with hydrochloric acid, makes borane gas, or diborane gas, which is pyrophoric, so it'll ignite when it comes in contact with the air. So the first thing I'm going to do is add some water to this, just to cover everything up. And then to the water, I'm going to slowly add hydrochloric acid. This should hopefully prevent anything from going awry. You can see it's already reacting with the water. We'll add the acid dropwise, slowly. See the bubbling speeds up significantly. So the hope is that this is going to get rid of the magnesium oxide, any leftover magnesium that didn't react, any leftover boron oxide that didn't really react, and any of the magnesium boride, and just leave some black boron as a precipitate in the bottom. That's the reason, by the way, that I didn't use aluminum in this reaction, even though I could have, because the product of aluminum oxide would not have been soluble in HCl, or would not have reacted with HCl, and so I couldn't have separated it from the boron. In using magnesium, I should be able to dissolve everything away, leaving only the boron left. So you can see that's a pretty vigorous reaction. So I'm going to do this really slowly, and we'll come back once the bubbling has subsided. So I ended up adding about 50 milliliters of acid to the mixture over the course of a couple of hours. I probably didn't need to do it for that long, but I just didn't want the reaction to get out of hand, because it produced a whole lot of gas and it got quite hot when I did it. So anyways, here's the products of it. You can see just a lot of black material floating around in there. And there's a layer of black on the bottom, which should be my elemental boron. So now all I've got to do is filter it off. And you can see in the bottom of the beaker there, I've got some flakes of potassium hydroxide just to neutralize the acid once I pour it out. Alright, here's my finished product, all filtered and dried. You can see that there's a little bit of impurity in there, a little bit more than I'd hoped. Those dots of red, like that one right there, are from the clay dish that I used, and also bits of sand survived as well, because they don't dissolve in the acid either. And the sand came from when I did the thermite. I usually do that on a bed of sand. So that's a couple of things that I'd like to change if I do this in the future to come out with a purer product. But the rest of this stuff, all the black, is going to be my elemental boron. Alright, so I'm going to test to make sure that this is boron. and I'm going to use an inoculating loop of nichrome wire. That's just a loop of wire, and I'm basically going to dip that into the boron and hold it into the flame of my propane torch here. And boron compounds are generally colored green, so I would imagine that if this is boron, it should burn green. And the first thing I'm going to do, by the way, to clean it off is dip it in hydrochloric acid, which I have there. So we'll get all this ready, and I'll show you what the flame looks like. Okay, I've got the wire coated in boron now. I'm going to put it in the flame. And that definitely has a green tint to it. There's a lot of yellow from sodium contamination. Even a little bit of sodium will totally discolor the flame. So even if there's only a small amount of sodium in there, that would show up pretty brightly. But there's very clearly a green tint to this flame. It may be a little hard to see on camera, but take it from me. It is indeed green, and that is boron. Thanks a lot for watching. I hope you enjoyed. This was a lot of fun to do this experiment, and I hope you had as much fun watching it as I did doing it.